Good morning, good afternoon, or good evening. So, now we will discuss yung second part ng ng discussion na nakalipas, which is yung ordinary differential equation. So, natapos tayo doon sa pag-introduce ng mga differential equations, etc. So now let's move on to the what we call homogeneous functions. So here, if we have a function f of xy, we can say that it is homogeneous in degree k in x and y, of course, dahil naka-depend sa x and y yung function natin, if and only if we have this particular condition. So if the function that depends on x and y, but this time with some factor lambda, and then we can show that it's equal to the function itself multiplied by some constant, let's say lambda raised to k. So where k is the degree, okay? So let's have an example. So we have the function x squared. So pwede natin isulat na f of xy ito. So we have f of xy is equal to, lagyan natin dito, okay, x squared minus 3xy plus 4y squared. So using our definition, let's see if this is a homogeneous function. So palitan lang natin yung x and y but with lambda x and lambda y. So magiging lambda x squared minus 3 times lambda x times lambda y plus 4 lambda y squared. So pinalitan lang natin yung x and y ng lambda x and lambda y. Okay, so as we can see here, pwede nating gamitan ng mga algebraic properties. So we can have lambda squared x squared minus x squared lambda, 3 lambda squared xy, and then 4 lambda squared y squared. So as you can see from here, pwede nating i-factor out yung lambda squared. So we now have lambda squared times quantity x squared minus 3xy plus 4y squared, which is the function itself. So now we have lambda squared times the function. So therefore, this function is a homogeneous function. So pwede natin sabihin din yung degree. So this function is a homogeneous equation of degree 2, which is yung nakita natin dito. Okay, let's have another example. So now we have f of xy is equal to x cubed plus y cubed. So let's do the same thing. Palitan natin yung x and y but with lambda x and lambda y. So mangyayari lambda x squared, lambda x cubed plus lambda y cubed. So ganun lang din. We can now have lambda cube x cube, lambda cube y cube, and then pwede natin i-factor out yung lambda cube, and then we have lambda cube times quantity x cube plus y cube. So this one is the function itself. So now we have lambda cube times the function. So therefore, this is a homogeneous equation of degree 3. So ganyan masasabi natin na homogeneous ang isang function or homogeneous yung equation natin. And pwede na natin masabi kung ano yung degree. Okay? So, let's have some theorem. So, given a differential equation, so we have the differential equation of the form m of xy dx plus n of xy dy is equal to 0. Okay? So, this is just a differential equation. So, let's have some theorem. If yung dalawang function natin na sinasabi dito, we have m of xy and n of xy are both homogeneous and of the same degree. So kagaya ng pinakita natin kanina, the function, yung ratio nila, which is m of xy over n of xy, is a homogeneous of homogeneous of degree 0, or is a homogeneous function of degree 0. So let's show the proof of these. So we have if we have m of xy and n of xy, we are both homogeneous in same degree, then gagamitan natin yung ginamit natin kanina na property, which is to substitute yung x and y with lambda x and lambda y. Okay? So palitan lang natin. So ibig sabihin nun, kung homogeneous, definitely dapat ganito yung maging form, no? So ganun din sa n of xy. So therefore, sabi natin yung ratio. So if we take the ratio of these functions, magiging ganito lang. So we still have lambda k times the function m of xy divided by lambda raised to k times n of xy. So kung mapapansin nyo, magiging, of course, we can cancel this out, no? Pero since we are trying to show na yung degree, so therefore, this is just lambda raised to 0, which is just 1. So therefore, this is a homogeneous function of degree 0. Right? So clear. So let's have another theorem then. Kailangan natin itong mga to sa pag-solve ng mga differential equations. So una, second theorem, if we have a function f of xy, and ito ay homogeneous with degree 0 in x and y, then itong f of xy natin is a function of y over x alone. So paano ba natin gagawin yan? We can let some variable y is equal to vx. So where v is also another variable, no? So therefore, pwede nating palitan yung y natin with vx. So magiging f of xy is equal to f of x and vx. So in this case, dahil nga sinasabi natin degree of 0 yung theorem, we can factor out yung x of 0. Now we have f of 1 v. So dahil 0 naman to yung exponent, this is just equivalent to 1. So therefore, we have this. Okay? So ganyan yung mangyayari. Now let's use an example to show this. So if you have a function f of xy, which is equal to x over square root of x squared plus y squared, palitan natin yung y with vx. So magiging ganito lang siya. And then, same function, now substituting y with vx. So kung titingnan nyo dito, magiging siyang x over square root of x squared plus quantity vx squared. So pag pinalitan natin yun, we can see na pwede nating factor out yung x. Kasi mayayari dito, no? Magiging x over square root of x squared times 1 plus v squared. Okay? So in this case, pwede natin makuha yung square root ng x squared. So now we have x over, factor out, labas natin x plus, times quantity 1 plus v squared. So now, this is it, what we have here. Okay? So in this case, pwede natin ding i-divide yung x sa x. So now we have 1 over 1 square root of 1 plus b squared. So makikita natin dito na yung function natin becomes this. And alam natin, since y is equal to vx, magiging lang siyang 1 over square root of 1 plus y over x squared. Kasi yung v natin is y over x from this substitution. So yan lang yung sinasabi ng theorem 2. Importante ito kasi pwede nating mas mapasimplify yung pag-solve ng mga equations natin. Okay? So let's discuss more yung mga properties. So if the coefficients m and n, which is yung function represented by the function sa differential equation na pinakita natin kanina, which is m of xy dx plus n of xy dy is equal to 0. If they are both homogeneous and are of the same degree, of course, in x and y, and pwede natin isulat na ganito. Okay? So now we have dy over dx plus the ratio of these functions is equal to 0. Okay? Paano nangyari yun? We just manipulated itong dalawang ito, no? So ipakita natin. So we now have, pwede natin gawin is, pwede natin ilipat muna, or pinakamadali is to divide. So now, tingnan natin, no? So we have m of xy plus n of xy. Sorry, may dx dito. Yung dy here is equal to 0, no? Paano ba natin magiging dy over dx? So we can divide everything with n xy dx, ano? So pwede natin gawin yun. Divided by n xy dx. So magiging makakancel to, may na lang m of xy over n of xy plus, since dahil pares to na n of xy, cancel yan. So now we have dy over dx is equal to 0. So this is exactly the same as this one. Alright, so hopefully malinaw yan. So using this notation, we can have dy over dx plus some function g that depends on y over x. So ito yan. Kasi pinakita natin sa isang theorem 2 na this one is a function of y over x alone. Okay? So yan, pwede natin ngayon palitan din. Kaya nag-introduce tayo ng variable v. So we can write this equation further. So palitan na natin yung y ng vx. So now we have the derivative of vx with respect to x plus g of v is equal to, pwede natin kunin yung derivative nito, no? So product rule lang. So now we have x dv dx plus v dx over dx, which is 1, okay, plus g of v is equal to 0. So kung mapapansin nyo, separable na yung mga variables. Kasi kung makikita nyo, nakadepende na lahat sa v, and then just may function, may factor lang tayo dito na x. Okay? So let's solve some, let's show some example. So solve the equation x squared minus xy plus y squared dx. So yung quantity yan, naka-multiply. Minus xy dy is equal to 0. So, pwede nating isulat ito based dun sa pinakita natin, no? So, this can be written as m of xy. And this one, xy, is n of xy. Okay? So, using yung form natin kanina, which is dy over dx plus m of xy over n of xy is equal to 0. So, palitan natin yun. We now have this equation, which is separable. Well, di pa pala siya separable, no? Kasi kung titingnan nyo, may kasama pa yung xy dito. And may y pa rin dito, no? So, however, dahil nga pwede natin gamitin ng trick na we substitute yung y with vx. So, here, pwede natin gawin yun. So, pag pinalitan natin yun, yung y ng vx, so we can have x squared. So, we have initially xy. So, may papalitan mo yun, magiging x squared v plus x squared v squared dx. Okay? And then minus, we have xy here. So, we have, pinalitan natin yung y ng vx. So, now we have x squared v. And then, since may dy tayo, no? Kung yung kakalimutan, since we have, we substituted yung y with vx, dy should be equal to v dx plus x dv. Okay? Product rule. So, ito yung katumbas ng dy natin. Is now equal to 0. So, yung pa rin yung original. So, we can factor out yung x squared. So, pwede natin may pakita na yung mangyayari dito is x squared tapos multiplied by this quantity, v squared minus v plus 1 minus, syempre may x squared pa rin dito, no? And then, sorry, hindi na pala kailangan kasi Nailagay na natin dito yan eh. Okay? So, since equal to 0 yon, pwede natin i-divide yon. So, mawawala na lang yung x squared natin. So, we can erase that. So, in this case. Okay? So, we now have itong quantity na to. So, we have v squared minus b plus 1 dx minus b squared dx minus x v dv is equal to 0. So, pwede natin pang isimplify ito. Anong pwede natin gawin? Since lahat to ay naka, mapapansin nyo, may dx dito, may dx din dito. So, if we multiply dx with each term here, we can have an expression na b squared dx minus b dx plus dx. Okay? And then, continue lang natin. We have this minus b squared dx minus x b dv is equal to 0. So, magka-cancel out to. Matitira na lang is v negative v dx plus dx minus xv dv equals to 0. So, this can be written as quantity 1 minus v dx minus xv dv equals to 0. So, ito yung form na pwede nating ma-simplify yung equation natin. Okay? So, kung mapapansin nyo, yung differential equation natin, DE, is now separable. So, pwede nating, ang sinasabi lang ng separable, yung lahat ng mga differentials mo, which is, halimbawa dito is dx and dv, can now be separated na kung saan yung mga variables mo ay nandun na lang sa isa. Kasi bakit? Ano ba ang goal natin? Is to get yung function. So, in this case, we can do the integration na. No? Kasi kung mapapansin nyo, all of these differentials depend on their respective variable. So in this case, itong dx, may 1 over x lang siya. Okay? Yung dv natin has v over 1 over v minus 1. So ganun lang yung mangyayari dyan. So in this case, we can now have, pwede nating paghiwalayin ito, itong term na ito, to 1 plus 1 over v squared times dv. So in this case, if you integrate, madali na makuha. So, the integral of dx over x is just ln of absolute value of x. And then in this case, meron ka lang dalawang term ng integration. So, yung una is dv, integral ng dv ay b. And then, since we have 1 over v minus 1, this is just equal to ln of absolute value of v minus 1. And of course, pwede natin i-represent yung 0 as ln of some constant. Okay? So, since everything here ay ln, we can do some mathematical equivalence, which is, or pwede natin sabihin trick. So, we have, pwede natin gamitin is e. I-erase, gagamitin natin yung both side na exponent sa e. So, we have ln of absolute value of x plus b plus ln of absolute value of b minus 1, is equal to e raised to ln of c. Okay? So, in this case, we can just take the absolute value. So, magiging na lang siyang, since exponent to, we can have, wait, may mas madali pala dito. Sorry, guys. Since ln ito, there is some property, no? Kapag nag-add ka ng mga ln's, pwede silang, pwede mo silang gamitin na, halimbawa, kapag addition, so itong dalawang to ln, no? So, this is just equivalent to product. Okay? So, pwede natin isulat na ln of absolute value of x times v minus 1, okay, plus b is equal to ln c. Ayan. And now we can just use them as an exponent. Sorry, it should be b. Okay, plus b is equal to e raised to ln of absolute value of c. So in this case, since nakaganyan na siya, there are some property ng ln, no? So, pwede natin paghiwalayin din. So, we have ln of absolute value of x times b minus 1 times e raised to v. Okay? Kasi exponent naman yan, di ba? So, is equal to e raised to ln of absolute value of c. So, may property ang ln. So, if you have e raised to ln of x, this is just equal to x. So, equal dun sa kung ano na sa ln. So, we can write this as x times b minus 1 e raised to b is equal to c. So, ito yung nandito kayo. Alright? So, it is necessary to know kung paano gagawin yan, no? Pero syempre, dahil napakita naman natin dito, okay lang din. Pero siguro sa mga exam or problem set, maganda ipakita natin itong ganitong steps. Alright? So, now, since itong nakuha natin solution, okay, ito, depends on x and v. But since gusto natin x and y, no, pwede natin palitan. So, since we have y is equal to dx, pwede natin ibalik yung substitution na yan. So, itong b dito can be replaced by y over x. Okay? So, now we have x times quantity y over x minus 1 times e raised to y over x. So, yung exp naman, alam ko hopefully, ang ibig sabihin lang naman yan is e raised to x. Usually, ginagamit to lalo na kapag mahaba yung nandun sa yung nasa yung exponent ng e para mas madaling isulat. Pero it doesn't matter naman kung pwede nyo isulat yan as e raised to y over x is just the same. Okay? So, let's use another example. So, solve the equation xy dx plus quantity x squared plus y squared dy is equal to 0. So, balikan ulit natin yung ginamit natin na technique. So, this can be written as dy over dx is equal to xy over x squared plus y squared. So, kung titignan nyo, this is a homogeneous equation of degree 2. So, you can try that naman, yung property. So, again, by substituting y with dx, we can rewrite this equation as this one. So, now we have x squared v dx plus quantity x squared plus x squared v times quantity v dx plus x dv. So, this one comes from dy here. Okay? So, we can factor out yung x squared, pero since may 0 dito, we can just divide that. So, mawawala yung x squared. So, matitira na lang is v dx times quantity 1 plus b squared times quantity v dx plus x dv is equal to 0, which can be written as this one. Okay, so we have dx over x plus dv over v times quantity 1 plus b is equal to 0. And now this is a separable. So, separate na yung v and x natin. So, marami rin pwedeng gawin, no? Pwedeng ka rin, instead of y is equal to vx, pwede rin x is equal to vy. You can also do that, no? So, if you do that, palitan mo lang yung x ng dy. So, you have this equation. Okay? Now, factoring y, ganun din yung mangyayari. If you factor out y, makusulat may equation as this one. Okay? So, you can double check this one para makita nyo rin. Ma-practice din kayo. And of course, we can integrate this one now. Right? Of course, kasama rin dito. Since 0 naman, ito parang equivalent lang siya sa constant. Okay? So, if we integrate this, hopefully, kabisado nyo na, we can have 1 over 4 times ln of absolute value of 2v squared plus 1 plus ln of y is equal to c. Or, since may property again, yung ln natin, pwede nating gamit ulit yun. Pero, pwede ulit natin pasimplehin. We can multiply everything by 4. Okay? In this case, mangyayari, wala na yung 1/4 dito, magiging 4 ln y. I just would like to note na since if nag-multiply ka ng 4 dito, this is 4c, magiging 4c, no? Pero we can still write that as c kasi constant lang naman. So it's just a matter of preference din. So of course, magiging iba yon kapag if we want to get the exact value ng c. Okay? Pero in this case, we are just getting the general equation. So just pwede natin gamitin lang yung c. Okay? So using the same trick, we use this as an exponent for e. So we will have this solution. So y to the 4th times quantity 2b squared plus 1 is equal to c. So ibalik lang natin yung substitution. We now have this solution. Medyo mahaba. Pero you can simplify that as this one. So you have finally y squared times quantity 2x squared plus y squared is equal to c. So ito na yung nakuha nating solution. Okay? So yun. Now let's discuss naman yung tinatawag nating exact equations. So if we have a function, capital F of xy, and then can be found that has for its total differential expression. So ito yung kanina din, no? M dx and dy. So tinanggal na lang natin yung m of xy and n of xy. Tanggalin na lang natin yun. So in this case, alam natin this m and n depends on x and y. So then, yung function natin, value ng function is just a constant. So ito yung set ng solution. Bakit set ng solution? Kasi yung c represents a real number or constant. So pwede maraming value yan, iba-iba. Diba? So kaya sa set of solution. So to the differential equation na meron tayo. Okay? So if this expression m dx plus n dy is exact, okay? Then by definition, yung f natin ay nag-i-exist na pwede natin isulat na ganito. Okay, kasi nga since equal to 0, pwede nating pakita na ganyan. So, however, ito yung definition natin ng total differential. So if we have, since yung function natin depends on xy, you can have partial derivatives of f that depends on these two variables. So yung total differential, df, can be obtained by taking the partial derivative of f with respect to x times the total differential of x, which is dx, plus partial of f with respect to y times the total differential. So yun yung magkakaiba nun, no? So d is the total differential. Itong curly delta is just yung partial. Okay, by comparison, we can see, so from here, saka dito, we can see na yung m is partial of f with respect to y, x, and n is partial of f with respect to y. So, using this definition again, so, pwede natin isulat yung partial of m with respect to y. If we take that, so, kunin mo na yung partial na ito with respect to y, so magiging siyang second partial derivative of f with respect, with partial y partial x. And then ito magiging yung n of x, partial derivative of n with respect to x is partial squared of f divided by or over partial x partial y. So, noting na dahil equal sila, itong itong ganitong expression. So ito yung equivalence ng ng differential, no. Kung titingnan nyo, kapag may ganitong klase ng mga partial derivatives, it doesn't matter kung ano yung unahin mo dito sa baba. So you can consider them as para mga variables lang din, of course. So provided that these partial derivatives are continuous, of course, importante lagi yan. Therefore, if this expression, m dx plus n dy is an exact equation, then itong nakuha natin, which is yung m and n, are equal. Okay? So, ang ibig lang sabihin nito, for this expression to be exact, it is necessary that the prior equation be satisfied. So, if you have this function, kailangan ipakita mo na equal mo na to bago mo masabi na equal itong expression ito. Alright? Okay? So, using that, let us have our third theorem. So, if n, and yung partial ng m with respect to y, and partial ng n with respect to x are continuous functions, of course, of these variables, x and y, then a necessary and sufficient condition that this expression, m dx plus n dy is equal to 0 to be exact, ito yung kailangan. So, kailangan mo yung ipakita na ganito para masabi mo na exact yung equation. Alright? So, the proof is given here. So, if we have, let's say, function of phi of xy, equal siya, halimbawa, if yung partial derivative niya with respect to x is m, pwede natin ipakita na yung pag yun may partial of m with respect to y, you just need to get the partial derivative of this one with respect to y. So magiging siyang partial squared phi over partial y, partial x is equal to partial m, partial y. And then, of course, similarly, we can get yung partial n with respect to x with partial squared phi over partial x, partial y. Okay? So, if we can integrate both sides, no, with respect to x, take note, if there are some partial derivative, you can take the other variable as a constant para hindi kayo malito. So, taking both sides, you integrating both sides with respect to x, taking y as constant, halimbawa, for this one, so you will have partial derivative of phi with respect to y is equal to n, kasi yung n natin is with respect to x. No? So if you integrate with respect to x, magiging n na lang siya. And then plus some function b prime of y. So this is just the derivative, di ba? So ganun yung mangyayari. So integrating both sides with respect to y naman, we have to take yung x as a constant, and we can get, ito pa rin yun, tutuloy lang natin. We now have phi of xy is equal to f of xy plus by, and tawag ito, dito lang siya galing, no? So yung b prime of y, magiging by lang. And take note, yung n natin is actually, yung definition natin kanina, the partial derivative of f with respect to y. So if we take the integral of that with respect to y, we can have the function of natin, which is yung capital F. Okay? So now, sabi natin, we can take the differential of f. Alright? So if we take the differential of f, the total differential, we just use the property kanina. So now we have partial phi with respect to x times total the differential of x plus partial of phi with respect to x times total differential of d of y, minus b prime of y dy. So dito lang din yan. Para hindi kayo masyadong malito. Right? Just take them as simple lang kasi hindi natin exactly alam kung ano yung form ng b. So using this, pwede nating ipakita kasi yung partial phi with respect to x is just m, and partial phi with respect to x is still m, no? However, in this case, pwede natin siyang pasimplihin. Sorry, there is a typo here. There should be y, sorry. So, ito yung magiging n. So, pwede natin ngayon isulat siya as n plus p prime y, dy minus b prime dy. And kung makikita nyo, we can cancel out yung b prime of y. So we now have m dx plus n dy, which is exactly what we have postulated na yung d of f is just equal to this one. Alright, so now we have Na-prove na natin yung theorem. Alright? So, ipakita na natin yun using some example. So, let's solve the equation 3x times quantity x, y minus 2 dx plus quantity x cubed plus 2y dy is equal to 0. So, if we take a look at this is a non-separable and non-homogeneous. Kasi bakit? Dito sa dx, it's being multiplied with variables ng x and y. And similarly sa dy, ganun din. So, hindi natin pwede gamitin iba nating nagamit. However, pwede natin gamitin itong technique na ito. So, importante ito. So, let's say if we have m dx plus m dy is equal to 0, pwede natin isulat ito as m and this one as n. Okay? So, ito yun. So, using our, yung pinakita natin sa theorem 3, we can take the partial derivative of m with respect to y. So, that is equal to 3x squared, right? And partial derivative of n with respect to x, magiging lang siyang 3x squared din. And you can see na equal sila, di ba? So, sabi nga natin sa theorem, if partial of m with respect to y is equal to partial of n with respect to x, yung equation natin is exact, di ba? So, or exact equation. So, therefore, yung equation natin ay exact. So, therefore, ang solution niya, di ba, yung constant lang. So, we can further show this. So, yung m natin can now be expressed as the partial of f with respect to x. So, paano yan? So, alam natin yung m, di ba? We just take the partial derivative of that with respect to x. So, we can have 3x squared y minus 6x. And then, yung n natin is partial of f with respect to y, which is equal to x cubed plus 2y. Right? So, we can integrate that. So, para ano, no? So, una, integrate the first one. So, ito, with respect to x, okay? Kasi yung itong f natin, nakadepende sa x. But taking note na yung constant yung y. So, we can have this expression. So, f is equal to x cubed y. So, dito yun, no? Constant yung y. So, ano ba ang integral ng 3x squared? That is x cubed. And then, minus 3x cubed. Okay? Saan siya galing? Pag kinuha mo yung derivative nito, magiging 6x lang. Right? So, plus some function of y. Okay? Laging kailangan yun kasi hindi mo sure kung ano yung i-add mo doon. Importante siya. Alright. So, now, by differentiating with respect to y, so, kunin natin ito, no? Kasi meron tayo dito para makuha natin yun. So, in order to do that, we just use this. Get the derivative with respect to y. So, now we have x cubed plus t prime of y. Yun yung partial natin with respect to y. However, yung n natin is equal to this. So, equate lang natin doon. And just by looking at this, we can see na yung t prime of y is just 2y. So, we have it here. So, in order to get the function t, since this is just the first derivative, if you integrate this or even just by looking at it, you will have t of y is equal to y squared. So, therefore, yung function natin is just this one. And pinalitan lang natin itong ty ng y squared. Alright? So, ito, yung nakuha natin. Ang sagot for f. So, ang solution natin, therefore, huwag natin kalimutan, this should be equal to c, no? Kasi nga, yung solution, kapag ang equation is just equal to constant. So, equate mo lang to sa c, sorry. Ito yung solution natin. Alright? So, yun ang sagot natin dito. Okay. We can have another example. So, solve for the equation x plus y times dx plus x minus y dy is equal to 0. So, you can see again, hindi siya separable, hindi rin siya homogeneous. However, we can use technique yung m and n. So, this can be represented by m. This one, pwedeng n. Okay. Lagi nyo tatandaan yung m is the one multiplied with dx and n is the one multiplied by dy. So, if we take the partial derivative of these functions, so partial m with respect to y is just 1, right? And partial n with respect to x is just 1. So, equal sila, di ba? So, exact yung solution, yung equation natin. So therefore, pwede natin gamitin ulit yung technique natin. So yung m can be is just equal to partial f with respect to x. So kunin mo lang yon, you have x, y. So as given by our yung assumption natin. And then n is partial f with respect to y, which is equal to x minus y. So again, taking the derivative with respect to x and y as a constant. Okay. So we now have, sorry, I think I made a typo. This should be integral. All right. Bakit integral? Kasi this is just f. So in order to get the sorry, this is just partial. In order to get f, you have to take the derivative. All right. So taking the derivative, we now have, para hindi kayo malito, I will write this. So we have partial f to m partial x. Okay. So if we take the integral of that, this is just f. So yung m natin is xy, sorry, x plus y, partial x, no? So taking y as a constant, kinuha mo yung integral nito, pwede natin paghiwalayin para hindi kayo malito. Okay? So this is just equal to x squared over 2. You can see here. And then this one is just, since constant ang y, xy. Okay? Since, again, mag-a-add tayo ng some function ty. Kasi, di ba pag nag-integrate, lagi may something na i-add. In this case, ganito lang muna. So now, if we take the derivative of that with respect to y, ito, we have x plus t prime of y. So again, this is n. Okay? Equate lang natin. So by comparison, we can see na yung t prime of y is just equal to negative y. So we have it here. And pag kinuha natin yung derivative niya, sorry, should be t. So t lang siya. T of y is equal to negative y squared over 2. Therefore, palitan natin yung t of y natin noon. So we have this solution. So dahil yung pag-exact is equal to constant, this is the solution for that differential equation. Okay? So maliwanag? Let's continue. So let's now discuss yung tinatawag nating first order linear differential equation. So doon sa previous discussion, we have shown yung general form, which is of an ordinary differential equation just given by this long equation. Okay? Yung first order, as we have hopefully naalala nyo, is just taking yung derivative na first order. Okay? And of course, yung term na walang derivative. So, ito lang yung first order natin. So, we have coefficient a sub 1 that depends on x times dy over dx plus a of 0 that depends on x times y is equal to some function g of x. So, laging importante na yung coefficient depends on x. Okay? And of course, yung nasa right-hand side also depends on x. Pwede siyang constant, okay? But definitely hindi pwedeng maging y. Alright? So, by dividing this equation by a sub 1, okay, pwede tayo makakuha ng ganitong expression. So, where yung a sub 1 na, yung p of x, okay, is just a sub 0 of x over a sub 1 of x. And of course, yung q natin is just g of x over a1 of x. Okay? Pinalitan lang natin ng another representation para mas madaling isulat. Alright. So, ito yung tinatawag natin na standard form for linear equation or linear differential equation of order 1. Order 1 kasi first derivative lang. Okay? So, now suppose that there exists a positive integrating factor. Okay? So, let's say v of x, which is positive. So, nakadepende lang siya sa x, no? pwede natin i-multiply yung buong equation natin. So both sides multiplied by that integrating factor. Ang sinasabi lang dito na this equation ay should be an exact equation. Okay? So we can rewrite this by multiplying yung v of x dito sa expression na to, and then rewriting them kasi magkakahiwalay na yung mga components natin, moving them all to the left-hand side to make the right-hand side 0, we have this expression. So b of x, quantity p of x times y minus v of x, q of x dx plus v of x dy is equal to 0. Okay? So kung mapapansin nyo, we have dx and dy here. So again, this is of the form m and n. Okay, this dy, this dx. Okay? So comparing that with this expression, we can have the m, which is equal to b p y minus bq, and n is just v. Alright? So para maging exact, again, ulitin natin, kailangan ito yung condition. So we can use that. So kung titignan nyo, yung bp natin is actually dv over dx. Okay? And this will give us, pwede natin pag-hiwalayan, kasi yung P natin ay nakadepende sa x. So P dx is equal to dv over v. So ito lang yung equivalent na to. And then we can take the integral. Okay? So we can have ln of v, ito, is equal to integral of v dx. And as you can see, dahil ln to, again, e raised to ln of x is just x. So we can have this expression. So this can also be written as p is equal to e raised to integral of p dx. So ito yung sinasabi ko na minsan mas madaling isulat as exp para makita natin na mas madaling isulat. Kasi exponent siya, baka makalimutan yung integral. Alright? So this shows that if ito yung kanina nating expression, no, has a positive integrating factor independent of y, kasi di ba inassume natin na yung integrating factor natin only depends on x, then the factor must be ito, yung nakuha natin kanina. Alright? So now let's apply yung factor, yung integrating factor na nakuha natin. So recall na ito yung expression natin kanina. Okay? And of course, yung integrating factor natin is equal to e raised to integral of p dx. So palitan lang natin, medyo mahaba, no? We can multiply yung integrating factor dito. Of course, for pxy din. So ganito lang yun. And then for q, still have this one. So anong pwedeng gawin? We can, again, i-move yung mga components sa left-hand side to make the right-hand side equal to 0. And then, isolate natin yung dx and dy para makuha natin kung ano saan equivalent yung m and y. Sorry, m and n. So therefore, here, itong mahabang expression na to is equal to m. And this one is equal to n. Okay? So ito yan. So, paano ba magiging exact? We have to show na yung partial of m with respect to y is equal to partial of n with respect to x. So let's do that. Ito yung partial of m with respect to y natin, no? Is just equal to px times e raised to or exponential integral p dx. So since para mag-exact, ito yung kailangan natin, and yung n natin is this one, we can take the partial derivative of n with respect to x. Ito yun. So kunin lang natin, just take the derivative. Okay lang na isulat na nito kasi nakadepende lang sa x lahat ng nasa right-hand side. Alright? You can also use partial, but in this case, this is more proper kasi dx dito. Okay? So derivative of that, since nasa ano lang naman yung pwede nating i-move yung derivative natin sa loob kasi this is just an exponent. So mangyayari, ano ba ang integral ng dx? E raised to x. So ex dx. Okay? Derivative noon. So we have e of integral of p dx times d over dx p dx. Okay? So, anong pwedeng gawin? Okay, we still have this one. Okay? And then if we take the derivative of this integral, you can see na magka-cancel out to, tapos magiging dp na lang. Alright? So, but the integral of dp is p. So, we still have px times e of integral of p dx, which is exactly the same as m of xy. So, therefore, we have shown na yung partial m and partial y is equal to partial n over partial x. So, exact yung ano natin, solution or yung equation natin. Alright? So, pwede natin isulat yung equation na to as this one para mas masimple lang. Okay? So, here is a summary kung paano natin magsosolve ng mga ganitong klase ng equation. Una, write the differential equation into standard form. Ito yon. Alright? So, second step is determine the integrating factor, which is just equal to the e raised to integral of p dx. So, given naman lahat ito, no? Kasi yung p of x natin is yung nakamultiply dito sa y. And then, sa third step is to use the integrating factor to sa standard form. So, you multiply yung integrating factor. Okay? Alright. So, then solve for the exact equation. Ang tawag sa method na ito is variation of parameters. Bakit variation? Kasi you use an integrating factor para makita mo na para mas madaling masolve yung equation. Alright? So, let's use an example para ipakita. So, solve the equation. 2 times quantity y minus 4x squared dx plus x dy is equal to 0. So as you can see from here, this equation is nonlinear and non-homogeneous. Alright? Of course, this is a first order kasi wala namang second derivatives. Alright? Isulat natin siya ngayon sa standard form. So in standard form, of course, kailangan i-manipulate ito. This can be written as this one. So we have dy over dx plus 2 over xy minus x, is equal to x, 8x. Of course, we have to take note na yung x should not equal to 0. Otherwise, magiging indeterminate. Alright? So this is a good way to practice. Gawin nyo to. Write this as this one. Right? So the integrating factor, of course, ay pwede natin kunin from p of x, diba? So in this case, ang p of x natin is 2 over x. So kunin natin yon. So e raised to integral of px dx. So ito lang yan. And then of course, pag integrate mo ang 2x, 2 over x dx is just 2 ln of absolute value of x. And then, dahil nakamultiply ito sa ln, this can be written as an exponent. So we have e raised to ln of x squared. Pwede natin itanggalin ang absolute value. And therefore, magiging lang x squared. Bakit? Kasi ang e raised to ln of x squared is just equal to x squared. Okay? Property siya ng exponential. Okay? So, third step, use the integrating factor. So, i-multiply mo ngayon lahat, yung left-hand side at right-hand side. Multiply mo. So, now we have x squared times dy over dx plus 2xy is equal to 8x cubed. Pwede mo rin isulat siya as ganitong form. Okay? Yung m and n natin. Okay? Huwag niyo kakalimutan yan. Kasi in this case, separable na ngayon. So not really separable, but mas madaling solve kasi we need yung m and n. So in this case, m is equal to 2xy minus 8x cubed, and n is just equal to x squared. So kunin natin yung partial derivative of f with respect to x. Of course, yun ay equivalent sa m, which is given by this one. Alright? So again, integrating with respect to x, holding or taking y as a constant. From here, we have this solution. So we can have f is now equal to x squared y minus 2x to the fourth plus t of y. Huwag nyo kakalimutan lagi ito kasi you have to add that. Dahil bakit? You only integrating with respect to x. You still have to consider yung y. Kaya ito yung nilalagay natin dito. Right? So dahil nga yung n natin is the partial of f with respect to y, we can take that by taking the derivative of what we obtained here with respect to y. No? So ito yan. Okay? So this is partial y. So itong buong to. Kukunin mo yung partial with respect to y. So we now have x squared plus t prime of y. And then note na yung n natin is this one. So magiging x squared. And by comparison, we can see na yung t prime of y is 0. So therefore, ano ba yung function na magbibigay sa'yo ng first derivative is 0? Constant. So pwede natin gamitin constant c. Hence, the solution is given by this one. So palitan lang natin yung t of x prime, yung t of xy as yung ty as c. Okay? Ito na yung solution natin. Alright. So an alternative solution is obtained by simply observing that kung titingnan nyo, itong expression na to is equivalent to this one. Okay? Kasi product rule. Okay? Integrating with respect to x, we can still get the same solution. So we can have two solutions naman. Of course, hindi laging ganito, no? Kasi ito madali lang yung nangyari. Pero of course, pinaka-safe na solution is to use yung mga nagamit nating TOM. Okay? So another example. So now let's use some initial value problem. Meaning, we are considering the function with some value na. No? Halimbawa, we have dy over dx plus y is equal to x, where y of 0 is equal to 4. Okay? So again, we can see, as you can see, this is a linear and homogeneous first order ordinary differential equation. Homogeneous na siya, no? Kasi nakikita nyo, this is only an x, and this one is ay naka-multiply by just a constant 1, and dito wala naman iba. Right? So, as you can see, yung form natin na dy over dx plus p of x y is equal to q of x. Ito yung form natin standard. So therefore, using comparison, p of xy is equal to 1. Okay? So using this, we can get the integrating factor. So integrating factor can be obtained using this. So e raised to integral of px dx, which is just equal to e raised to integral of dx. Ito ay equal lang sa x. Kasi ang integral ng x ay dx. So this is e raised to x. Alright? So multiplying the whole equation with our integrating factor, we now have this. Okay? And by integration, madali na. Kasi e raised to x lang naman, we can have this solution for this one. Okay? So we have quantity y minus x times e raised to x dx plus e raised to x dy. Okay? So as you can see, meron na tayong function for m, and meron na rin tayo for n. So using this, we have these values. So again, we can use the value for m in order to get the partial of f with respect to x, and this is just equivalent to this one. And if we integrate that, we have this one. Sorry. Okay, and comparing that with n, which is just equal to e raised to x, making ganito lang siya. And by comparison again, as you can see, wala naka-add dito, so 0. Okay? So t prime of y is now equal to 0, which is just a constant. So therefore, the solution is just this one plus kung ano yung t of y, which is c. So magiging ganito na yung solution natin. Right? So, however, wala natin kalimutan, meron tayong initial value. Ang sinasabi lang nito, if this is y of x is equal to 0, is equal to something. So y of 0 is equal to 4. If x is 0, y is 4. So ganyan yung sinasabi. So gamitin natin yung solution natin na nakuha. Ito yan. Okay? So if x is 0, y is 4. Palitan natin yung x ng 0 and palitan natin yung y ng 4. So e raised to 0 times 4, ito yan, minus quantity, palitan mo ng 0 to, palitan mo ng 0. So we have 0 times e raised to 0 minus e raised to 0. So this one will be cancelled out. Ito magiging 1 lang. Since negative to, may negative dito, magiging plus. This e raised to 0 will become 1. So we have 4. 4 plus 1 is equal to c, which is equal to 5. So therefore, the final solution, yung tinatawag nating particular solution, is this one. So yung una, na silang yung nakalagay, that's the general solution, meaning family or set of solution. Kasi yung C can be represented by any constant. However, since we are given an initial value, yung makukuha natin sagot is a particular solution. Alright? This can be written differently, pwedeng ganyan, or of course, pwede mo i-separate yung Y and X. But it's okay. It doesn't matter naman kung ano yung makuha nyo. Unless explicitly asked na isulat nyo in terms of X yung Y. Alright? So another way is actually to begin with this expression. Of course, sometimes kasi may mga differential equation na you can guess kung ano yung solution. Okay? Pero hindi, medyo, it's an acquired skill. Just to be safe, you can use this method, of course, pero kung familiar kayo sa ganito, okay lang din naman. Alright? So you will get the same answer. Okay, so hanggang dito na lang muna yung part 2 ng OTE natin. And hopefully may natutunan kayo. And if you have any questions, you can send an email to us. Okay, or you can consult. Okay, so yun lang muna. And hope to see you soon sa next na mga lecture. Mapanood nyo. And have a nice day.